Hello, my name is Matthew West, and this is my presentation on bony versus cartilaginous fish for Chapter 4, AICE Marine Science. The first slide shows the table of contents and what we're going to be navigating while going through the slide. Our first slide is a comparison of fish summaries. Now, bony fish are in the class Osteichthyes, and they have main features including an operculum, lateral line, and gill slits, while cartilaginous fish are in the class Chondrichthyes, and they have both types of fins, 2 pectoral, 1 caudal, 2 pelvic, 1 anal, and 2 dorsal. They also have tooth-like skin called denticles and gill slits behind the eyes. This is a close-up of a generic bony fish. As you can see, they have an operculum and their lateral line expands the length of the body and all of the different types of fins. And here is a cartilaginous fish, which has the same amount of fins. The caudal fin is labeled and the gill slits are not protected by an operculum. The next slide shows comparisons between the organs and structures. So the first up is the skeleton structure. Well, bony fish in the name suggests that it has a hard skeleton, but also in the class Osteichthyes, where osteo means bone. Cartilaginous fish, on the other hand, also in the name and the class suggests that they have cartilage instead of hard skeleton. For buoyancy, most bony fish have a swim bladder, which allows them to inflate and deflate depending on how high they want to raise in the water, while chondrichthyes or cartilaginous fish need to rely on the fatty parts of their body and special fins. Lastly, their scales differ. While bony fish have overlapping softer scales called cycloid or stenoid scales, cartilaginous fish have tooth-like scales called placoid scales, or the skin that we mentioned in the first slide called denticles. The next slide talks about chordates, which both fish share the same phylum, and it talks about similarities between their structure while they're developing. The first is the notochord, which is an organ extending the length of the body and it helps with muscle contractions. The dorsal neural tube is a same cord that extends the length of the body, but instead develops into the brain and spinal cord. The pharyngeal slits have many uses between Osteichthyes and Chondrichthyes. This includes water filtering, gill slit structure, and a link for the digestive system. Lastly, the post-anal tail helps in swimming movement in the rear, and in Osteichthyes and Chondrichthyes can turn into the anal fin. The next slide is about taxonomy and binomial nomenclature, where both bony and cartilaginous fish share the same domain, kingdom, and phylum, Eukarya, Animalia, and Chordata, where the differences go inside of the class, where one is Osteichthyes and one is Chondrichthyes, one meaning hard skeleton and the other meaning soft skeleton or cartilage. Here are some different taxonomy examples. On the left with the West Indian Ocean coelacanth, which is a type of bony fish, you can see that it has domain Eukarya, Animalia, and Chordata. Same for the right, the great white shark, Eukarya, Animalia, and Chordata. Where it differs is with the class of Osteichthyes and Chondrichthyes, and then the last four are unique to the different fish species. Here are more examples of bony and cartilaginous fish. Bony fish contains the Atlantic tuna fish, coho salmon, and Asian carp, or cartilaginous fish like the great white shark, northeast skate, and giant manta ray. As you can see, bony fish tend to be the ones served at restaurants more than cartilaginous fish. Why does understanding differences between these fish matter? Now, many fields of study in the real world require these specific groupings, so you're able to carefully measure, record, and observe the different types of data, and being able to understand the differences between bony and cartilaginous fish can help researchers understand why they're getting different results for these different types of fish. Thank you for listening to my presentation on marine organisms for Chapter 4.